This question says that a ladder leaned against a frictionless wall. If the coefficient of the friction with the ground is mu, what is the smallest angle that the ladder can make with the ground and not slip? So we should keep in mind of this and not slip. To solve this, let's try to divide this into two. I think the forces are quite shown, it's clear. So we consider this part, which is decide to divide this. So I have this to be, okay, the distance from here to here is d1, and the distance of this will be d2. So if I consider the full triangle, I'll be having this, and here is d2, this is theta, so, and this is length. Then from this we can write that d2 is equal to L sine theta, and if we decide to cut the small parts, this will be L divided by 2, and here is the d1. We can say that d1 is equal to L over 2 cos theta. And we're given a condition for the ladder not to slide. For the ladder not to slide, we have that the torque will be equal to 0. The torque must be equal to 0, and we can write that this will be equal to 0. 0 is equal to minus mg d1 plus n2 d2. So this is the net force, and the reason why we are having minus here is because of the clockwise and the counterclockwise rather of the force. This is pointing down. If we have a mass and the force is pointing down, the torque will be in this direction, which is the clockwise, and you have a negative force, the negative. So but for the counterclockwise, you have this and is pointing up, and this will be coming down. So, and you have positive. So for this, it's the weight is pointing down, and that's why we have this to be negative. So we already have our d1 and d2 to be this. Okay, let's just put it. So this we have minus mg d1 is L over 2 cos theta plus n2 or L sine theta is equal to 0. So if we decide to simplify this, we'll be having that n2 L sine theta is equal to mg L divided by 2 cos theta. So, and we can have that n2 will be equal to mg divided by 2 L cos theta divided by L sine theta. So the L can cancel L. We'll be having that n2 will be equal to half mg and cos theta sine theta will be 1 divided by tan theta. So let's simplify. For the ladder not to slide, we have that n2 must be less than or equal to the frictional force. FF. So, and we have that the FF will be equal to mu and mu static, and we've already gotten n to be mg, so we have that the F will be equal to mu s g. So, and since we have this expression for n2, then we can write that for the ladder not to slide, or mu s, for the ladder not to slide, we have mu s mg must be less than or equal to half mg 1/tan theta. So, and we have this to be, okay, let's clear the mg, can cancel the mg, and we have mu s to be 1/2 tan theta. So, and we can say that tan theta will be equal to, this will be greater than or equal to 1/2 mu s, and theta will be equal to, will be greater than or equal to the arctangent of 1/2 mu s. So this is the point at which the ladder would not slide.